A generic is essentially a function template and allows us to define placeholders for its types. As an example, let's consider these two functions. Both functions have the exact same logic, the only difference is that one returns a number and the other returns a string. So instead of having two functions, we can define a single generic, and let the developer that uses it choose which type they need. Let's remove everything up to the first function. We're leaving it as a reference while we build the generic one. Now let's define our generic, so, function, logger, and then we add a pair of angle brackets. Inside the brackets, we add what's known as a type parameter. A type parameter can be any letter or word, but the convention is to use T. This comes from C++, where generics are called templates, and use the T. This T is what we're going to use to specify the type when we call the function. So let's just add the parentheses and curly braces, then go below it and say logger. Now here we have to add the angle brackets again, and specify the type we want, like number. Now we can use T in the function wherever we want the same type, like the message parameter. So now in the function call, we'll have to use a number, like 30. If we try to add a string, we'll get a compilation error. Just like with the parameter, we can use T as a return type, and then we can return message. At this point, it's exactly the same as the function at the top. But now we can call the generic again, this time with a string as the type. Okay, but we want the generic to actually log the message to the console, so let's change the return type to void, and log the message to the console. And if we save, we'll see both get printed. Just to demonstrate that other types can be used as well, we'll do another logger with a boolean that's true. Okay, everything works like we expect. Let's remove this top function, we don't need it anymore. Let's say we want to limit the types in our generic function to only numbers and strings. To do that, we use the extends keyword. So let's go in the angle brackets and do T extends number, or string. Now we'll get a compilation error on the boolean, saying that it doesn't satisfy the constraint, so let's remove it. And by the way, TypeScript can infer the type we want from the parameter, so we can remove these, and if we save, we'll see everything still works fine. We're not limited to using just primitives, we can do something like an object with a name, of type string. Now we can only pass objects that conform to this specific shape. We can also do classes and interfaces, so we'll go up here and define a class called animal. Then we'll do a parameter property called name. And constrain the generic type to animal. In the function call, we'll do new animal, Mickey Mouse. This works, but we can also do classes that inherit from animal. So let's create a new class called dog that extends animal, and we'll do another function call with a new dog, Goofy. We're not limited to only generic functions, we can have generic classes too. As an example, let's create a custom key value store. So, let's remove all this and do class key value store, and like with functions, we specify the generic type in angle brackets after the name. This time though, let's do two types, with T and U. In the body, we'll add a constructor, then public key as T, and public value as U. Okay, let's instantiate a new key value store. Then we'll specify the types we're using, so let's do number for the key and string for the value. And finally, we'll initialize the object with a number and string value. Now, like with functions, we can omit the types if we're initializing the object with values. To demonstrate that it works, let's console log the key and value. Okay, it works just fine. That's it for this TypeScript course, we hope you found it useful. Thanks for watching, and don't forget to subscribe for more tutorials.